Hey guys, I'm continuing straight on from the previous video. So we've found f.df. The next thing we need to find is this k3 term, so that was 0.3. So k3 is from section 9.3.4.2a. So if we go back to 9.3.4.2, so going back to that section, so 9.3.4.2, you can k3 is simply just taken as 1.0. So that's pretty simple. K3 shall be taken as 1.0. So K3 is 1.0. The next thing we need to find is this change on LEF. So that's the deflection limit, so 2.3.2. So if we go over to that section, 2.3.2. So you can see here in table 2.3.2, we have deflection limits, the limits for calculated vertical deflections of beams and slabs. Now we're going to be dealing with all members is the case we want to do. So for all members, we want the deflection limit for spans. So that's the one we're dealing with. There's cantilevers as well, which we're not dealing with. We're looking at spans. Deflection to be considered, we're looking at the total deflection, which is what we want to be looking at. So deflection limit for slabs is 1 on 250. Okay, so that's the value we want to take. Change on LEF equals 1 on 250. The next thing we want to find is the elastic modulus of concrete, so that's going to help us as well. Now that is just from the problem, we found that in the first video, 3100. Elastic modulus of concrete, 3100. So far, just to show you what we've found from the values, we don't know that, we don't know that. We've found K3, we've found that value, and that value. So the only unknown values at this stage are the length, the depth, and K4. Now, what's going to happen is we're going to be doing in the next video, is we're going to be isolating different slabs. Okay, you can see that there's 3 different types of slabs in this problem. There's this one, and this one, and they simply repeat. That one's repeated there and